Imagine standing on a windswept coast. The sea is a churning, angry beast, smashing against the shore with relentless power. Now imagine trying to build in it. Not just a small jetty, but a colossal harbor, a safe haven for hundreds of ships. For most of ancient history, this was an impossible dream. The sea was untamable, a force of nature that defied human ambition. Yet one civilization didn't just try. They succeeded on a scale that baffles engineers even today. We are, of course, talking about the Romans. Their mastery over the land is legendary. Roads, aqueducts, the Colosseum. Our story takes us to the coast of modern-day Israel. Here, submerged just beneath the shimmering surface of the Mediterranean, lie the ruins of a truly magnificent port. This is Caesarea Maritima. It was a city born from pure ambition, a metropolis conjured from a barren strip of coastline around 22 BCE. The man behind this grand vision was King Herod the Great, a client king of Rome. Herod was a master builder, but Caesarea was to be his crowning achievement. He wanted a port that would rival Alexandria in Egypt, a symbol of his power, and a vital economic link to the heart of the Roman Empire. There was just one problem. The coastline here is notoriously difficult. It's straight, sandy, and completely exposed to the violent storms that sweep in from the west. There are no natural bays, no protective islands, nothing to offer a ship shelter. So how did they do it? How did Roman engineers build a solid, stable breakwater in the middle of the churning sea? The answer lies in a remarkable invention: hydraulic concrete. This wasn't just any concrete, a special mixture that could be poured into water and set, hard as rock. The key ingredient was a special volcanic ash. The Romans called it pulvis puteolanus, Pozzolana. Found in the volcanic fields around the Bay of Naples near Puteoli, modern Pozzuoli, fine sandy ash, a gift from the volcanoes. When they mixed Pozzolana with lime and water, it made a mortar of incredible strength. It could set in the absence of air. Mixed with chunky aggregates, tough rock, broken pottery, it formed waterproof concrete that would harden when exposed to seawater. A chemical reaction occurs between pozzolana and lime in the presence of water, forming calcium silicate hydrate, a stable, insoluble compound. To truly grasp the significance of this achievement, we need to listen to the experts, both ancient and modern. The first-century historian Josephus, who witnessed Caesarea in its glory, wrote with awe about its construction. He described how Herod overcame the difficulties of the location by pouring immense stones into the sea. Josephus marveled at the size, wide enough to house buildings on top. Modern archaeologists who have dived on the site express a similar sense of wonder. Dr. John Olson, a leading expert on Roman harbors, has spent decades studying Caesarea. He states, "The Romans were the first to understand how to make hydraulic concrete on an industrial scale. What they did at Caesarea was revolutionary. They were essentially creating instant geology." Materials scientist Dr. Marie Jackson has analyzed samples from Caesarea and other Roman ports. Her research reveals that interaction between volcanic material and seawater over centuries forms rare, incredibly stable minerals. For nearly 2,000 years, the magnificent harbor of Sebastos lay sleeping beneath the sea. Its story faded into myth. But in the 1960s, a new era of exploration began. Edwin Link, an adventurous American engineer and inventor of the flight simulator, turned his attention to underwater archaeology. Using a small submarine and advanced diving gear, he and a team began systematic exploration off the coast of Caesarea. What they uncovered exceeded expectations. Not just scattered stones, but ghostly outlines of a massive man-made structure. Visibility was often poor, and the scale of the ruins was hard to grasp from the seafloor. Divers began clearing sand and seaweed, and a clearer picture emerged. Huge blocks of concrete appeared, some over 50 tons. They identified the distinct form of the breakwater, the entrance to the harbor, and the foundations of the towers. Following the initial discoveries, the exploration entered a new high-tech phase. They turned to sophisticated remote sensing technologies to map the entire underwater site with unprecedented accuracy. One key tool was side-scan sonar. Towed behind a boat, it sends sound waves that bounce off the seabed. The sonar images were a revelation, revealing the full extent of the northern and southern breakwaters. They also use sub-bottom profilers that penetrate the seabed to reveal buried foundations. This allowed them to see the foundations and to understand how deep the Romans had built. Core samples, long cylinders of material, were brought to the surface, providing a cross-section of the breakwater. These data, combined with GPS, allowed creation of a detailed three-dimensional model of the entire sunken harbor. Researchers could now walk through the ancient port on a computer screen, calculate volumes, and quantify the logistics. Mapping the breakwater was one thing, understanding its brilliant design was another. Archaeological evidence revealed the Romans were following a sophisticated, multi-layered construction plan. Primary structure used the caisson method. Giant, hollow wooden boxes floated out, sunk to the seabed, and used as formwork. They poured hydraulic concrete to form huge monolithic blocks, the solid core of the breakwater. But the genius went beyond material science. The Romans understood wave dynamics in a way that seems modern. On the seaward side, they created a spending beach, a wave-dissipating, sloping face made of rubble and blocks. This absorbed energy before waves could strike the main wall, dramatically reducing stress on the primary structure. Archaeology suggests the inner side had open arches, allowing water circulation to prevent siltation. The southern breakwater's gentle arc helped deflect wave energy and channel currents away from the entrance. At the end stood a colossal lighthouse guiding sailors safely into port. The discovery and study of the breakwater at Caesarea have profoundly changed our understanding of the Roman world. It shatters the old-fashioned image of the Romans as simply great soldiers and administrators. It reveals them as master scientists, innovators, pioneers of materials and techniques. This was knowledge not surpassed until the modern industrial era. The ability to ship thousands of tons of Pozzolana to Judea demonstrates an interconnected Roman economy and sophisticated supply chains. The harbor was an economic engine, moving grain, soldiers, luxury goods, and ideas across the empire. This is literal proof for claims made by writers like Josephus and Vitruvius. Roman engineers put advanced knowledge into practice on an epic scale. Their sunken masterpiece is a classroom on the seabed, teaching us about human ingenuity. It reminds us innovation is not limited to our time. As we stand in the 21st century facing our own unique set of challenges, the secrets of the Roman breakwater offer more than just historical curiosity. They hold profound lessons for modern builders, engineers, and environmental planners. Perhaps the most important lesson is about durability. We live in an age of planned obsolescence. Modern Portland cement is energy-intensive and can degrade quickly in marine environments. Roman hydraulic concrete points toward a more sustainable future for construction. Pozzolanic materials and industrial byproducts like fly ash can reduce the carbon footprint of concrete. Researchers today study Roman chemistry to create greener, stronger building materials. They designed systems that worked with the sea, wave-dissipating walls and self-flushing channels. Lessons for resilience. Build with vision, innovate with purpose, create a legacy that will endure for millennia. The ghosts of the Roman engineers have shown us the way.